So, hello students. This was asked by as a doubt by one of your classmates. So, I thought I will put it here so that others who have or having similar doubts can benefit. So, the question is, there are a series of questions. I can see one on AP. So, okay, the sum of the first three terms of an arithmetic progression is 42. So, okay, sum. So, A is the first term. Second term is what? A plus D. And the third term is A plus 2D. So, sum of the first three terms is 42. And the product of the first and the third, this is the first term. This is the third term. The product of the first and the third term is 52. That is A into A plus 2D is equal to 52. Okay. So we have the sum of the first three terms. Let me, you can do the sum in another way also. Okay. So which I will take it up later. I don't want to confuse you now because tomorrow is an exam and this has come as a doubt. So I'll just, in the straightforward plain method, I will teach you. So A, and A. That's what? 3A plus 3D is equal to 42. Okay. So I'm just summing them up. That's what it says, no? The sum. You take out 3 common. A plus D is equal to 42. So, or divide throughout both sides by 3. 3 14 3s are 42, isn't it? 3 14s are, so this is equation 1. And the next equation that I have is A into A plus 2D is equal to 52. So, I can do this sum in different ways. In the sense, you can call this as equation 2. I can do it as substitution method, that is Sridharacharya's method. I can use, I'll be using it for quadratic, but of course, first I have to substitute here because I'll not be going with inspection here. It'll be a little difficult here because A plus 2D is involved, isn't it? And both are variables. So what I will go do is, I will substitute D as, now look here. So what is it? Just scroll down here. So A plus D is 14 or D is equal to 14 minus A and put that value of D here. So what do you get? You get A into A plus 2 into D. What is D? D is 14 minus A. Okay, this is substitution, but it's in a quadratic and we'll see what happens next. So that will be A into A plus 14 2s are 28 minus 2A is equal to 52. A into 28 A and minus 2A will give me minus A is equal to 52. Okay, so this is what I get. Now, if you look at it, you can actually do this in different ways. Remember, and when banking and when you're calculating N, I told you can use this method of inspection. I can use that also here. Let me just give it a try. I can get 52 as 13 4s are 52. I can get 26 into 2 is 52. And 52 into 1 is 52, isn't it? There are different ways. How about I'm just trying out something. I just happened to see that 26 is near to 28. Okay. So this is just a trial and error. So 2, I can put A as 2. 28 minus 2 is 52. Because what am I getting precisely? 2 into 20, 52. No, 52 it is. So I'm getting, wait, okay. 2 into 26 is 52, isn't it? And, or I'll just write this. I can write this. So in the place when you compare, you're getting A as 2. So you can put A as 2. This is one way of doing it. But what if I'm not able to identify? This is just for us to kind of do a quick fix or a cross verification. But I'll actually open this out. So A into 28 minus 8 is equal to 52. So I'll get 28A minus A square is equal to 52. Coming down, I have to come down. So I get 28A minus A square minus 52 is equal to 0. Or I can, I can write A square minus 28A plus 52 is equal to 0. It's a convention. Generally, we don't want the first term, that is the A square term, to have a negative sign. It's just a convention. And it helps in the ease of calculation. Now you can use Sridharacharya's formula, or as I said, you can use the splitting the middle term, 26 into 2, but I will not go with 26. I'll go with minus 26 into minus 2. I want a positive product, isn't it? So 1 into 52 is 52. And because I want negative 28, that's the reason I chose two negative factors. So 1A square minus 26A minus 2A plus 52 is equal to 0. So you can club these two, 1a into a minus 20, or you can just say a, 1a is a minus 26. I've taken out a common, and here you can take out, you can write 52 as 2 into 26, right? So you can take out minus 2, you can take out common. I'll be left with a, and I want a plus, right? So minus into minus, 2 minus 26 is equal to 0. So that gives me what? A minus 26 into a minus 2 is equal to 0. So a is equal to 26 or a is equal to 2. Okay. Now let's see what happens. Now let's go back to, D is equal to 14 minus a, isn't it? So we go back there. So D is equal to 14 minus a. So there are two possibilities. When a is 26, what happens? And when a is 2, what happens? So when a is 26, so what is D then? 14 minus 26, isn't it? That will be negative 12. So it's a decreasing AP for in the first case. And second case, when A is 2, D is equal to 14 minus 2, which is 12. So it is an increasing AP. So what I can do is, let me take the first term, second term, third term. That is in the case when, what is it? When A is 26 and D is negative 12. And I can take A is 2 and D is positive 12. So I get first term, second term, third term. I'll just plug in those values. It's just a cross verification process. Not that I really have to go about doing this. Okay. Because you go back to the question and see, what does it say? Find the first term and the common difference. We've already found. And we have said that there are two possibilities. Okay. Now, if they put a clause or a criterion like it's an increasing AP or it's a decreasing AP, then we'll have to go with it. There's nothing mentioned, so we'll take both the conditions. First is A is 26, D is negative 12. Next, A is 2 and D is positive 12. So first term is A, isn't it? Second term is A plus D. Third term is A plus 2D. Again, the same thing, A plus D. I'll just write it once and then we will substitute. So, okay, so what happens? What is A in the first case? 26. So 26 minus 12, which will be 14. And 14 minus 12 is 2. Okay. In the second case, when it's a increasing AP, what is A? 2. And 2 plus 12 is 14. And 14 plus 12 is 26. Technically, I got the same set of numbers. It's just that one is an increasing AP, one is a decreasing AP. You can check. As per the condition, when you add the first and the second and the third, that is the first three terms, what do you get? 14 plus 2 is 16. 16 plus 26 is 26 plus 26 is 42, isn't it? And the same here, 2 plus 14 plus 26. It satisfies the criterion. The sum of the first three terms is 42. Okay. Next is the product. Product is first and last term, A into A plus 2D. That is 26 into 2 is 52. Or here also 2 into 26 is equal to 52. 26 into 2 is equal to 52. And here also 26 into 2 is equal to 52. So it satisfies both the conditions, the first and the, so we have found out. So in this case, remember, there are two ways of looking at it. One is an increasing AP, one is a decreasing AP. So let us move on to the next sum, which is, okay, fine. I'll just duplicate this so that I can write it here also. Fine. So in the interest of space, I'm just doing this. So this is clear. I hope this has been clear. No, I just went a step ahead, and I actually solved and I verified. You don't have to do that. You have found the A and you can actually stop here. I just wanted you to appreciate it practically and so you can get two different APs. Actually, it's not two different APs. It's like just that the first three terms, if you think that the AP has only three terms, finite AP, you're going to swap the positions. That's all. So it is going like this. You're just turning it like this. That's all. Okay. So let's come back to the matrix sum. It's given that, okay, this sum is given 4, 2, minus 1, 1, m into m is equal to 6i. So there is a matrix which is given to me. It's a 2 by 2 matrix, 4, 2, minus 1, 1 into another matrix m. I still don't know the order. Let me see. It is equal to 6 into I, where m is a matrix. So, and I is a unit matrix of order 2 by 2. So 6i means unit matrix. 6 into 1, 0, 0, 1 is a unit matrix, isn't it? And I told you the unit matrix is equivalent to the number 1 in matrix terminology, and this gives you 6 into 1, 6, 0, 0, 6. So, like, see, when you have a 2 by 2 matrix, and then you are getting another 2 by 2 matrix, if the order of M matrix is x by y, let's say, so the number of rows should be equal to the number of columns, isn't it? Number of columns of first matrix should be equal to number of rows of the second matrix. So 2 is equal to x. And finally, you're going to get 2 by y, 2 by 2, isn't it? The y 2 comes from this y. So that's why we understand that the matrix M also should be a 2 by 2 matrix, right? So this is clear. So matrix M is a 2 by 2 matrix, which means 2 into 2, 4 elements will be there. What do I do now? So the first part is clear. What is the order of the matrix M? It's a 2 by 2 matrix, isn't it? Because this matrix 2 by 2, the column should be, the row should be 2, that we understood. And the resulting matrix, that is 6, I know, 6, 0, 0, 6, that is also 2 by 2. So this can only happen when this y is equal to this 2. Okay. I hope you are getting the logic here. So that is clear. Now the next thing is to find the matrix M. Okay. Actually speaking, there are different ways of doing it, because later on when you in college level, you will have concept inverse of a matrix. When you do the inverse of a matrix, you can do this, right? Because when you, like, any number into its inverse, multiplicate inverse will give you 1. So that same concept is in matrices, but right now we have not studied inverses, and this is not up to the scope of your ICC grade 10. So we will not go with that method. Just letting you know that, just a foresight that this is there. You can actually do it using the inverse techniques. Now, no need that. So what we'll do is, we don't know the matrix M. All I know is that there are 4 elements. So we'll take the elements as, A, B, C, D. Any 4 elements. That is, this is representing my matrix M. And that will be giving me 6, 0, 0, 6. So now it's just simple matrix multiplication. This is the testing and knowledge of matrix multiplication. So what we do, 4 into A, 4A, plus 2 into C, 2C, 4A plus 2C, first row, first column. Next, first row, second column, 4 into B, 4B, 4B plus 2D, 4B, 4B plus 2D, 4 into B, 4B plus 2 into D, 2D. Okay, first row, second column. Next, go to second row, first column. I get minus 1 into A minus A plus C. Next, minus 1 into B is minus B plus D. Okay. So that will give me 6, 0, 0, 6. Okay, this you need to be careful. Now equate the corresponding elements. I hope this part is clear to you. 4 into 2, 4A plus 2C, 4B plus 2D, minus A plus 1C or C, and minus B plus 1, minus 1B plus 1D or minus B plus D. I'm just dropping the coefficient 1. It's understood, no? So now it's, you just look at the coefficients. See, you equate the corresponding coefficients, that is the corresponding entries I'm saying. So minus A plus C is 0, isn't it? See, if you look at it, minus A plus C is 0, or C is equal to A. So in technically, now you, first row, first column position, here also first row, first column position, that is 6 here. So equate the corresponding coefficient, corresponding elements. So 4A plus 2C is equal to 6. Just now we have found that C is equal to A. So in the place of C, I can put A, or in the place of A, I can put C. So 4A plus, instead of C, I can put 2A is equal to 6. 6A is equal to 6, or A is equal to 1, which means C is equal to A. So C is equal to 1. So we have got two, what do I say? The two elements we have got of the matrix M. I need the other two. Again, the logic is the same. So here you equate the first row, second element, second column element to first row, second column element. That is 4B plus 2D is equal to 0, isn't it? So you get 2D is equal to minus 4B, or you get D is equal to minus 2B. You get D is equal to 2 into minus 2. D is equal to minus 2B. So once that is done, then equate second row, second column to second row, second column. That is minus B plus D. You can see here I'm circling it, isn't it? This one. Minus B plus D and 6. You have to circle, you have to equate them. Minus B plus D is equal to 6. That is second row, second column, second row, second column. You can minus B. D, what is D actually? D is minus 2B, right? You can put minus 2B is equal to 6. Giving me minus 3B is equal to 6, or B is equal to 6 by minus 3, which is negative 2. 6 by minus 3 is minus 2. And what is D? D is equal to minus 2B. Minus 2 into minus 2, which is equal to positive 4. So I actually have got all the entries. If you see, I got, what is it? Yeah, A is 1, C is 1, B is negative 2, and D is equal to positive 4. So my matrix M will be what? 1, how would I name it? A, B, C, D, no? A, B, first row, A, B, then C, D, yeah. Okay, A, 1 minus 2 is B, 1 is C, and the D is 4. I can always cross check, isn't it? As per the condition, what is it? That matrix 4, 2, minus 1, 1, 4, 2, minus 1, 1 into M is 1, 1, minus 2, 4 should give me 6i. Let 6, 0, 0, 6. Let me check. This is just the verification. See, I'm just going a step ahead because when we do sums and when we, in the exam, we'll not have time to sit and verify. But when we do this, it's a check for ourselves. It's a reality check for ourselves. Okay, I've done it correctly or not. Okay, we just cross check. 4 ones are 4. So I get 4 ones are 4. For 2 ones are 2. Minus 4. I'm sorry, minus 4 into minus 2 is minus 8. And 4 into 2 is 8. Okay. Minus 1 and plus 1 plus 1, 1. And minus into minus plus 2 ones are 2. And 4 ones are 4. So it gives me what? 6 minus 8 plus 8, 0. Minus 1 plus 1, 0. And 6. See, that is equal to, I can take out 6 common. 1, 0, 0, 1. Technically, that is equal to what? That is 6 into I, which is the identity matrix of order 2. So this is how you will go about doing it. Okay, you'll get 4 equations, but it's not really very difficult because you get a lot of interdependency, like A is equal to C and B is equal to minus 2D. So this is how you work out these kind of sums. This one is on AP and one is on matrices. I'll get back with more doubts in my next session because in the interest of time, and I'm not able to will not be able to upload such a huge video. So I'll come in the next session. I hope this explanation has been helpful to you. Okay.